Good morning, Internet! It's a lazy Sunday morning and a great day to sit around in my jammies with Cars the cat. My name is Adam. We're going to look at a little internet puzzle that showed up in my feed this weekend and pick it apart right after this. Question is, what is the units digit of 7 to the power of 64? So what's the last digit in the decimal expansion of that? We're given a choice of 5, 3, 2, or 1. Now, it sounds like a lot of work to go and multiply it all out manually. So we could cheat, and let's do that. We can plug that into the internet and see what we get. And you'll notice that we don't get really what we're looking for. We something to the power of 54. So that's not going to happen for us. So we've got to break this down. Now our choices are 5, 3, 2, and 1. So when we multiply 7, we just 7 to the power of 1 is just 7, and then 7 squared is 49. So that ends in 9. Now 7 times 49, 7 cubed. Well, that's going to end in 3 because 7 times 9 is 63, so there's going to be a 3 and you're going to carry the 6. Okay, so that's going to end in 3. And so you're going to have a number. When you get to 7 to the 4th, you're going to have a number ending in 3 that you're going to multiply by 7. And 7 times 3 is 21, so whatever that number is, you're going to put down the 1 and carry the 2, so it's going to end in 1. And then now look what happens. The next number is going to end in 7, because 7 times 1 is 7. And the one following that is going to end in 9. So what we've got is a cycle from 7, 9, 3, and 1. 7, 9, 3, and 1. There's only 4 different ways that this thing can end. There's only 4 different ways that a multiple of 7 can end. So 7 to the power, so it cycles in groups of 4. So 7 to the power of 64, 64 is divisible by 4. So after we multiply 7 by itself 64 times, we're going to be at the end of a cycle of 4. So that means that the last digit of this long number is going to be 1. So, yeah, we've solved the problem. But, how else could we have looked at this? And what if the problem had been asked in a different way? Okay, so, the choices are 5, 3, 2, and 1. Okay, now, there's a couple of numbers that we could have even eliminated from the beginning. 5. 7 is a prime number, and any number ending in 5 is a multiple of 5. So we could have eliminated 5 right away, and the same goes for 2. 2, any number ending in 2 is going to be an even number. It's going to be a multiple of 2. So a power of 7 isn't going to end in 2. So that leaves just 3 and 1 as possibilities. So if we had to guess, we've already got a 50% chance of getting this right. Now, can we do a puzzle like this with other numbers? For example, how about the base 7 expansion of 10 to the 64? How would we solve that? Play with this a bit and give your thoughts in the comments, and maybe we'll come back to this. Thanks for watching, and I think I'm going to maybe go back to sleep and think about this for a bit.